Hello, this brief video is to further explain the count by thirds empirical rule. We'll start by looking at this simulated data set, but it's meant to simulate an authentic type of data set. The context is that we have measurements that have been measured in centimeters for an instrument that is cutting a particular length, and the lengths have been measured to make sure that they're falling in a particular range. And what we see here is that we have 200 measurements, and the average of these measurements is 80 centimeters. And the standard deviation turns out to be almost exactly 3 units. Now, it's kind of in a strange order because it snakes along instead of goes up and down the columns. But here's the data set where it's been actually put in order, and we can very clearly see that the minimum value is 72.7, and it goes all the way up to the highest value of 87.62 centimeters. Now, if this data is normally distributed, then it should follow the empirical rule. The empirical rule says that about 50% of the data should fall within 2/3 of a standard deviation above and below the mean. With a standard deviation of 3 units, 2/3 of 3 is just 2 centimeters in this case. So that means that about 50% of the data should fall within 2 centimeters above and below 80, or between 78 and 82. So what this graphic shows us is the values that actually fall in that range, the values that are larger than 78 but less than 82. Turns out there's 99 data points in this data set that fall into that range. 99 over 200 is 49.5, which we see is pretty close to 50%. The shaded values in the data are the values that fall in this range, and the shaded areas in the tally plot for the histogram, which is oriented on its side but still can be interpreted as a histogram, shows the values that fall between 78 and 82. The next part of the empirical rule says that 70%, or about 70%, of the values should fall within 3/3 or 1 whole standard deviation above and below the mean. One standard deviation is about 3 centimeters. 3 centimeters below 80 is 77. 3 centimeters above is 83. So we would expect to see about 70% of the data fall within 77 and 83 centimeters. Here we can see the shaded values. These are the values that actually fall within that range of 77 to 83. And we see that that turns out to be 137 values, which is 68.5%, which is about 70%. So the approximation is pretty close. Again, we can see the shaded region indicated on the tally plot as well. Continue with the empirical rule. If we move out 4/3 of a standard deviation above and below the mean, that would take us to the values 76 and 84. We see that there are 167 data values in that range, which accounts for 83.5% of the data, which again is close to 80%. Stepping out 5/3 of a standard deviation above and below the mean takes us to the range of 75 to 85, in which case there are 180 values that fall in this range. 180 divided by 200 is 90%, which in this case happens to be exactly what the empirical rule predicted. Moving out 2/3 of a standard deviation above and below the mean would take us to 74 centimeters to 86 centimeters. In this range, we see that there are 186 values. Out of 200, that's 93%, which once again is close to 95%. And last but not least, if we go 7/3 of a standard deviation above and below the mean, that would take us 7/3 of 3 is 7 centimeters. So that would take us 7 centimeters below 80 to 73, 7 centimeters above 80 to 87, and we see that there are 195 values that fall between 73 and 87 centimeters. That's 97.5% of the data, which once again is close to 98%, which was predicted by the empirical rule. And when we look at the histogram, we see that this data set does indeed appear to fall a nearly normal distribution. So the percentages we found, which seem to align relatively well with the empirical rule, are a good sign. In the next video, I'll show how to work some problems that allow us to predict the possible ranges in which we would find certain percentages of the data. Thanks for listening.